This week, we will moving forward to Chapter 7 and continue to talk about that in next week. So Chapter 7, we will talk about the integer arithmetic. So we already talked about the addition and subtraction instruction, but we don't have a chance to introduce multiplication and division. So that's what we'll do that in Chapter 7. But before that, in Chapter 7, the multiplication division we will introduce next week. This week, let's do some other instruction that will also possibly have the division and multiplication happen. But this one is even more. We will do the shift and the rotate instruction. And the shift and the rotate instruction, actually we will work on the bit. So let's talk about the shift instruction first. So then we will talk about the rotation and application on Thursday. For the shift instruction, we have two kinds of shift. One kind is we call logical shift. So that will be the SHL and SHR instruction. And we have the arithmetic shift. So that will be the SAL and SAR instruction. So SHR, did you remember you saw that before? Did you remember when we want to change the text color? We have the foreground color and the background color. So then in order to set the background color, we have the color number. Instead of multiply by 16, we do the SHL. Actually we see the SHL, okay, because we move to the bigger. Yeah, so that's why we talk about that in Chapter 5. So we see more detail what is SHR and SHL. So the first thing we see what is the shift instruction. Like earlier, we say we have two kinds of shift, right? So we talk about the logic shift first. So just like the SHL we talk about in Chapter 5, we can move the bit to the right or left. So this one is we call the logical shift. You can either decide to shift each bit to the right or to the left. But one thing you can think about, since every time you go to the right, so then if we just say each bit will shift to the right, so then you will have one, actually they are open. So this one, we have nothing to shift into. So this one, if we say that's logical shift, the open up space we fill up with the 0. So that's what we call the logical shift. So here, one thing is when we shift to the right, so then actually the most least bit, they will also shift. They always shift into the carry flag. So when we have the open up space, we fill up with 0, that's logical shift. But if we have the open up space, we call that the arithmetic shift. Actually, we fill up the newly opened up position with the sign flag. It's not the sign flag, the sign bit for the original one. For example, we see this one. We shift one bit to the right. Okay, so this bit will be open up. So then we will, according to this bit, actually is the sign bit is the most significant bit. We use this sign bit to fill up the original one. So actually you can see here, if we say the arithmetic, we consider they are sign integer. So then your most significant bits being opened up, actually we just keep them the same using the sign bit. So that's two different kinds of shift. So the first thing we see in detail, what is SHL and SHR. So when we see the SH, that means shift. So the L means you shift to the left. So SHL shift to the left instruction actually perform a logical shift you to the left. So that's why this one is our original bit, 1 0 0. So you have 1 byte, right? So you have your 8 bit. So if we say the shift to the left, right? Okay, so then that means each bit move 1 bit to the left. So the first one to shift, actually they have no space to shift to. We always shift to the carry flag. So on the other hand, you see here, when you shift to the left, you just move 1 bit to the left. On the other hand, this one go to the carry flag. So this will go to the new value. So our new value will become 1 0 0 1 1 1 1. So then here, actually you have 1 open up, because this one is we call the logic shift. So they fill out with the 0. So when you do the SH operand syntax, you can see actually they always has 2 value. So you source operand is the first one. So which value you want to work on. So then how many bits you want to move. So that's why when you do the SHL, so your destination operand can be register, can be memory operand. But one thing is, then how many bits you want to shift, they need to be immediate value. If you really want to use the register, they only allow CL. So on the other hand, at the most, we only can do the 1 byte shift in the value. Okay, so you will see here, for example, I want to shift the DL 1 bit to the left. So that's why here we have the DL value is the decimal 5. So that will be 4 and the 1. So that's 101. So here, when you do the DL shift to the left, you just shift each one to the left. So the first 0 go to the carry flag. So then you are 0, 0, 0, 0, 1, or 1. So you fill out with the 0. So did you notice that this one is we talk about in chapter 5, right? So when you shift to the left, okay, depends on how many bits you shift to the left. So if you only shift 1 bit to the left, actually make their value double. Why? You see here, originally the decimal value is 5, right? So after we shift 1 bit to the left, they become 10. The reason is I told you in chapter 5, when you move to the left, just like the decimal number, we have originally, if we have the decimal number 5, okay, so if I shift to the left, they become, let me write it down. You see, when you have 5, we just say it's regular 5 in daily life in our algebra. If we say the 5 shift to the left 1 bit, you will have 5, right? Then you fill out with 0. So that's why did you see 5 become 50? So that's 10 times bigger. So if you shift 2 digits to the left, right, then become 500. So that's why 1 bit you shift to the left make your value 10 times more. That's because we are in base 10 algebra life. In algebra, in our real life, our base is 10. So that's why shift to the left for 1 bit, you become 10 times bigger. But in our assembly language or computer world, our base is what? Yeah, our base is 2. So that's why whenever you want to shift to the left for n bit, that means you multiply. It's just like you multiply by 2 to the nth power. Okay, the base is 2. How many bits is the n? So that's why on the other hand, for example, you want to make your DL value multiplied by 4. So on the other hand, you just need to shift the L 2 bits to the left. So that's the shift to the left. Shift to the left to make your value become bigger is multiplication, right? So now can you guess how about shift to the right? So the shift to the right instruction perform the logic right shift, right? So the same thing, I shift to the right. So this first one we shift to the right, they will move to the carry flag. So this open up, we do the logical shift. So of course they fill out with a 0. So then when we shift, for example, we shift n bits to the right, actually just like you divide by 2 to the nth power. Okay, so this one the same thing. Just like the real life, we are base 10, right? So 50, if I say 50, shift to the right for 1 bit. You see, so decimal is here. 0 to after the decimal, so the value become 5. So that's why in the real life algebra based as 10, you shift to the right for 1 bit, make you become like the divide by 10. So the same thing in the computer world, because our base is 2. So you shift to the right n bit, like you divide by 2 to the nth power. So for example, you can see if we have DL is 80. So 80, if we convert to the binary number, that's like 80. Okay, because you have 64 plus 16. So then you see you shift to the right. This one we see that's the binary, right? So you shift to the right, they become 001011 101000. So you see here is 1, 2, 4, 8. So 8 plus 32 become 40. So you see 80 become 40. You shift to the right, they become divide by 2. So then you shift to the right again for 2 bits. So we can guess 40 will like divide by 2 to the 2's power. So that's why it become 10. But here is we prove this one, if we shift 2 bits to the right, so that's why they become 1010. Then the front fill out with the 0. So that's 10. So here we do the shift instruction, but actually they are just like, you can use that like the multiplication or division. So that's the logical shift. So when we talk about the logical shift, we have SHL, SHR. But when we talk about the arithmetic shift, we only have SHR is different. So when we see SHA, SAL. So you see if you shift to the left, right? Remember earlier we say the arithmetic shift, we just have the open up, need to fill out with the sign bit. But here when we shift to the left, the open up is here. So that's why here if that's the most, it's the least significant bit, we just still fill out with 0. So SAL and SHL, actually they are the same, because the least significant bit fill out with 0. So the only way we'll have the most significant bit open up, that's your shift to the right. So that's why we have SAR, that's do the arithmetic shift to the right. So how many bits you have? So the least significant bit still go to the carry flag. But when we have the most significant bit open up, they just fill out with the original sign bit. So that's why when you have your DL equal to the negative 80, so when we consider you are working on with the sign bit, you want to, on the sign value, you want to do the shift. Then you need to do the SAL or SAR. So we see SAR. So here we try to move to the right for 1 bit. So then that's the negative 80. So this one I need to use 2's complement to find negative 80. So when you shift to the right, they become negative 40. So then the same thing.